Hello everyone, Assalamu alaikum. Welcome to another exciting tutorial on deep learning. In today's video, we'll dive into the fascinating world of multi-class classification using neural networks. And we'll be using the powerful Keras library to build and train a model. So this video is going to be helpful for you if you want to learn about how to build and train a model using machine learning algorithm. Before we jump into the code, let's take a moment to understand what multi-class classification is, where we aim to classify data into more than two categories. For example, classifying images of different animals into categories like dog, cat, bird, and so on. It's unlike the binary classification where we have outcome in the form of 0 or 1 or yes or no. Here we have multiple options available as an outcome, and the algorithm select one class out of multi classes that we have. It's also different from the multi-label where we have multiple outcomes. So this is the primary difference between binary classification and multi-class classification. Tackle multi-class classification will be harnessing the power of neural networks. Neural networks are a type of machine learning model inspired by the human brain. They consist of interconnected layers of artificial neurons, also known as nodes. Each node receives input, performs computations, and passes the output to the next layer by adjusting the weights biases of these connections. Neural networks all learn patterns and relationships in the data. In code, we'll be using the Keras library, a high-level neural network API, which provides a user-friendly interface for building and training neural network models. So here is our sample training dataset. We'll be having two inputs or two features, and we'll be having one label and or label data, and the first input will be our height of fall and the second input will be height of embankment, and the label would be the type of predicted retaining wall. So what we are going to do is in this model we are going to give our model two inputs that are height of wall, that is our retaining wall, and the height of embankment, and the model is going to predict the suitable retaining wall for the given heights. So let's move to the code. So here we are going to do our programming part in the Google Colab. So the first thing that we are going to do is we are going to start by setting up. So let's begin by importing the necessary libraries. The first library I'm going to import is pandas as PT. This is a powerful data manipulation library in Python. And the next one that I'm going to import is NumPy. Um, NumPy provides support for large multidimensional arrays and mathematical functions. So to split our data into training and validation sets, um, I'm going to import train test split. So from SK selection selection import train test split. So the text library that I'm going to import is the label encoder and standard scalar classes from scikit-learn's preprocessing module. These classes are used for data processing tasks like encoding labels and scaling features. So from scalar dot pre-processing pull label encoder standard scalar. So now we're going to import the sequential class from the Keras library. Sequential is a linear stack of neural network layers from Keras to models import sequential. The next one, I'm going to import dense class from Keras. Dense represents fully connected neural network for Keras dot layers import dense. The last library I'm going to import is load model function from Keras. This function is used to load saved model. Now I've imported all the necessary functions, classes, and the libraries that I need for my program. So now I'm gonna run the program and all the things have been imported successfully. So the next thing I'm going to do is loading training dataset. So I'm gonna load the training dataset. So we can pull the files module from the Google Colab package. This module provides functions for uploading and downloading files in Google Colab. So from Google Colab, import files, loaded, go to file, dot, upload. So uploads, it uploads a file machine to the Colab environment, and the upload file is assigned to the uploaded variable that I've just created here. So the next thing that I'm going to do is use pandas to read my CSV file and store the data in the data variable. So data equals to pt dot read CSV data set dot CSV. So basically, you might be thinking over here that how I can name without uploading the file. So I was just coding it once, and I had already saved the names of my file as dataset.csv. So I'm gonna run it, and it is going to give me the option choose file. Here is my file, 100% done. So here you can see that saving dataset.csv to dataset.csv. So my data file containing the training data, the input features, and the label data has been uploaded to the Google Colab environment. So now the data has been uploaded. The thing that I'm going to do is pre-processing data. So the data is in the raw form. I'm going to preset process my data before the data is going to be used in the neural network. So to standardize our input columns and label column, we'll be using technique like scaling our input features using standard scaler from scikit-learn that we have just loaded, and scikit-learn encoding our class labels using label encoder. So I'm going to code this as scalar is equal to standard scalar. So now our data has been pre-processed. The next thing that we are going to do is splitting our data into training and validation sets. So splitting data into train and validation sets. Right. So let's split our input data and target data into training and validation sets by dividing into ratio 80 and 20. So x is equal to data. So our data has been loaded, our data has been pre-processed, and data has been split into train and validation sets. So now comes the exciting part, that is building a neural network model using Keras. We'll create a sequential model and add multiple dense layers with different activation function. So the next part is model creation. So create an instance of the sequential model for Keras. This will be used as the neural network model. Model is equal to sequential so we are going to add fully connected layer with 32 units and value attribution function to the model. Model dot add dense 32, sorry, 32, and the activation function is value input to item is equal to 2. It basically specifies the input shape as 2 corresponding to the two features in the X. We're going to add another fully connected layer with 16 units and yellow activation function to the model. Now I want to add the output layer with 4 units and the softmax activation function. The softmax activation function is suitable for multi-class classification tasks. Model add dense for duration is equal to softmax. So let's run it to see problem and solve it. Okay, syntax error. Okay, I didn't put I comma here. So let's run it again. Okay, now our model has been created. Now the next step that we are gonna do is to compile our model. So we'll compile a model by specifying the optimizer, loss function, and evaluation metric. This step prepares our model for training. So model dot compile. So our model has been compiled, and we have used the Atom Optimizer. Atom Optimizer is used, which is an efficient variant of stochastic gradient design, and the sparse categorical cross entropy loss function is suitable for multi-class classification tasks with integer labels. The accuracy matrix is used to evaluate the model's performance. So that we have compiled a model, so it's time to train a model. We use the fit method to train a model on the training data, specifying that the number of epochs and batch size. We'll also monitor the model's performance from the validation set. So train a model. So model model dot fit x train y train epochs is let's put it somewhere right 200, and our batch size would be 32, and validation data equal to x and y dot. I hope there are no syntax error this time. Anyway, it's just run it and check it. Uh-oh, this happens when you are doing online video. So I put brackets on epochs. So I guess here we went wrong. So now just run my run the code with 200 epochs. Yes. So basically, these are the iterations that are being carried on our model, and our model is being trained. So 198, 192, 200. So here you can check that these are different values of loss and accuracy that has our model had. And now it will choose the best of the weights and biases depending upon all these epochs. So what we'll do, we'll check the accuracy. So accuracy equal to model dot evaluate x train y train. Okay, so here we can see the accuracy is equal to 0.7 is 78%, and loss is equal to 0.48, and it has chose these two values from above epoch values, and this is the best thing considering the weights and biases. So the next step that we are gonna do is to save the model. Saving model, and model dot save. I'm gonna name it as train model, trained model dot at 5. That is the file format. Okay. So once a model is used, we can save it for future use, and we have saved it in the HTF5 format in the same method provided by Keras. So far, what we have done, let's recap. We have imported all the necessary libraries, then we brought it to training data set, and then we pre-process our data, and then we split the data into training and validation sets, then we created our model, then we compiled our model, then we trained our model, and then we have saved our model. So now that our model is saved, let's use it to make predictions on new unseen data. We'll load the saved model and pre-process a new input using the same transformation we applied during training. So what we're going to do is pre-processing new inputs for prediction. So new input one is now what we're going to do is loading our saved model. Loaded model is equal to load model trained model dot h5. So now model is loaded, and we're gonna do prediction. So prediction is equal to loaded model dot predict new data. So our model will predict now from the new data that we're given above, and predicted loss is equal to numpy dot arg. Next, we're going to use the arg here to predict the one with maximum prediction probability. Predictions is access to 1. You got it. Prediction is equal to label in color for inverse trans sorry transform predicted class and print it class go to prediction 0. Okay, so now we're going to predict given our inputs that are 0.5 and 4.7. So let's see. Oh, it's LP once again. Okay, no problem. So here we go. Our model has successfully predicted the outcome, the type of retaining wall, and that is ST, that stands for stone retaining wall. So if you have So what we've done, we've given some input features to our model and some label data, and the model has predicted against the unseen data, that is 2.5 units and 4.7 units, and the model has predicted that we should be going for stone or gravity wall. So what we have seen in this video is how to like build a neural network model and how to train that neural network model and then how to make predictions around it. So I hope you would have learned a lot about multi-class classification, the whole process that how we do the program in the Python and how we make predictions. Do not forget to like, share, and subscribe to this channel for future helpful videos regarding civil engineering and programming. Thank you so much.